Hello everyone, welcome to IMS Gate Academy. Myself Vipin Mishra, the lead mentor at IMS Gate Academy, and I welcome you all in this Gate Score Booster series of IMS Gate Academy. So we were covering the subject signal and system in this series, and part 1 I have already covered, in which we have discussed 22 best questions, right? And through that you got a fantastic practice, right? So in this part 2 I'm going to cover some other important questions and important topic. So let's get started. So this is going to be your first question. See this question. In this question, what they're asking is that a time domain signal ht has Fourier transform, and this is the Fourier transform. Then what is going to be the value of h of t at t equals to 0, right? So this is the Fourier transform of some function. Now what will be the value of h of t at t equals to 0 we will get? That is what we have to find. So see, we can adjust this h of omega. It is 1 minus cos square omega, whom we can write sin square omega divided by omega square, right? This we can write in this way. 1 by 2 we can write here, and then we have e to the power j omega plus e to the power minus j omega. Now sin square omega upon omega square is sample omega square, so we can write it 1 upon 2 sample square omega e to the power j omega plus 1 by 2 sample square omega e to the power minus j omega. So this is how we can adjust this h of omega, right? Now we have this h of omega, in which, just see, this is h1 omega and this is h2 omega. So what we can see, that Fourier or frequency domain is sample square. Now you have to recall, when we get the frequency domain as sample square, then you will figure out, then when the time domain is a triangular signal, then the frequency domain is sample square, right? What I'm trying to say is that if you have a triangular signal, if you have a triangular signal in time domain, then the frequency domain will be sample square, right? So if we have a triangle t by tau in time domain, then the frequency domain after taking Fourier transform will be a tau sample square omega tau by 2, right? This is what we will get. Up now, if I compare these signals that we have, so what do we have here? We have half sample square omega, right? Half sample square omega, or we can adjust half later on. Just see sample square omega, right? So just see, we are getting sample square omega in frequency domain. So what could have been the time domain? So this is how you can judge it. The time domain could have been a triangular pulse, correct? Time domain could have been a triangular pulse. So we are going to get a triangular pulse. Now what will be the value of this a and this tau? So in this signal, if you are going to compare it with this one, the value of a tau is 1 and the value of tau by 2 is also 1, right? So from here tau will be 2, and from here the a will be 1 upon tau, or 1 by 2, right? So I can replace these values here, and I can write that it is going to be 2 and minus 2, and the magnitude is going to be 1 by 2, right? So this is how you can judge that sample square omega, what is the inverse Fourier transform of this, correct? What is going to be the inverse Fourier transform of this? So sample square omega is now known to us. So if I do right now sample square omega into, we are multiplying e to the power j omega, right? So in the frequency domain, is if exponential is coming, this is because time domain was shifted, okay? So now we will shift the time domain. So shift the time domain, and how much shifting? Just see, e to the power j omega t naught. So t naught value is 1 here. So we will shift it by we will shift it by 1, right? Here the positive power is there, so we will shift by +1. So shift this signal +1. If you are going to shift this signal +1, -2 will become -3 and 2 will become 1. So you will get something like this. Okay, this will become -3, this will become 1, this is 1 by 2, and this will be 1 by 4. Okay. Similarly, if you will write sample square omega e to the power minus j omega, now this has to be shifted on the left side. So right now what you will get is shift this signal towards the right side by 1. So you will get it -1 to 3. Right, this is -1, this is 3, this value will be 1 by 4, and this value is 1 by 2. Correct? So this is your H1T and this is going to be your H2T. Correct? This is your H1T, this is your H2T. Now what we have to find is, see, what will be H of T here? So 1 by 2 you can take common, okay? 1 by 2 you can take common here, okay? And this is H1T plus H2T. Now if I calculate that what is going to be the value of H of T at T equals to 0, then this is going to be half of H10 plus H20. The value of H1T at T equals to 0 and H2T at T equals to 0, both are 1 by 4. So 1 by 2, 1 by 4 plus 1 by 2, 4. Okay, so 1 by 4 plus 1 by 2, 4 will be 2 by 4 or 1 by 2. 1 by 2 into 1 by 2 will be 1 by 4. Okay, so you will get 1 by 4 or 0.25. Right? This is how you can get the answer of this question. Okay. So in part 1 also we have discussed the importance of, if we have time domain, a rectangular pulse, frequency domain will be sample. If we have time domain as triangle signal, frequency domain will be sample square, right? These two are very important results. If you will practice these results, surely if there will be a question in GATE exam, you are going to solve that question easily. So I hope this question as well as the answer is clear to you all, right? So this is how we can solve this particular question. It was a very good question. Now move to the next question. See this one. X of omega is rectangular, omega minus 1 by 2, then Fourier transform of t xt e to the power minus j2t will be what? Okay, so we have been given a Fourier transform which is a rectangular pulse in frequency domain, right? Rectangular of omega minus 1 by 2. So first of all, get this signal. Rectangle of omega minus 1 by 2. If I draw the signal rectangle of omega, so see, this is rectangle of omega, just omega, right? So what I will write it, if I just draw rectangle of omega, so it is 1 by 2 here and minus 1 by 2 here, and the magnitude is 1, correct? Now we need to shift it by minus 1 by 2. So now just shift this signal by minus 1 by 2 and draw another signal rectangular of minus 1 by 2. So shift this signal by minus 1 by 2 and you will get signal like this. Right, this will become 1. This is rectangle of omega minus 1 by 2. Okay. Now after that, just do the scaling. Once you will do the scaling, then what you will get? Now we have to do the scaling of 1 by 2 and we have to draw another signal rectangle of, we already had omega minus 1 by 2. Now we will be doing the scaling of 1 by 2 in omega, and rectangle omega by 2 minus 1 by 2 will come. So after doing scaling, what this will become? What this will become after doing scaling, you will get, just do the scaling. So it will be 0 to 2. Correct? This duration will become 0 to 2. So this is the signal that we have, rectangle omega by 2 minus 1 by 2, omega by 2 minus 1 by 2 or omega minus 1 by 2. So you got your signal. Now what we have to do, they are asking that what is going to be the Fourier transform of txt e to the power minus j2t. So we are multiplying with time, and after that, not only that, we are going to shift it also. Okay, so see, let's suppose that you now have x of omega in terms of waveform. So x of omega, it has Fourier transform x of t has Fourier transform x of omega. If suppose I am going to multiply e to the power minus j2t in it, then what will happen? The frequency will be shifted and you will get x of omega plus 2, right? So x of omega is already there with us. Now what is going to be x of omega plus 2, right? So see, this is our x of omega. Now I am going to draw x of omega plus 2, right? So let us draw x of omega plus 2. So if I am going to shift this signal by plus 2, then what will be the signal? Then the signal will be just like this. Correct. The signal will be just like this, having magnitude 1. This will be minus 2. This is our x of omega plus 2. Now after that, I have multiplied this signal by t. T e to the power minus j2t x of t. Multiplication of t. Multiplication of time in time domain will result in differentiation in the frequency domain. So what I will get? I will get here j d by d omega of x of omega plus 2. That means I have to differentiate it. X of omega plus 2. X of omega plus 2 is a rectangular pulse. When you will differentiate it, then what you are going to get? Tell me what you will get. So after differentiation, right? See, this signal is moving like this. So it's a form, it's in the form of rectangular signal. After differentiation, it will become impulse, right? So we will get one impulse here at minus 2, right? And we will get one impulse here at 0, having magnitude, having weight of 1, right? So this is d by d omega of x of omega plus 2. Now just write this signal. So if we are going to write this signal, which we have differentiated, this signal will become what? J times what we will get is del of omega plus 2 minus del of omega, right? J del of omega plus 2 minus del of omega. Okay, and I think we got our answer, isn't it? This is what we are trying to find, t e to the power minus j2t xt. So it is j del omega plus 2 minus del omega, and which is given in option number B, and that is going to be the right answer, right? So see what we have done. First of all, you need to recognize what is rectangular omega minus 1 by 2. So have the signal rectangular omega, then do the shifting, which is done first, then do the scaling, which is done after shifting, then you will get your signal. Then apply the property, right? First, frequency shifting property, shift the signal, get the frequency shifted signal. Then multiplication in time is equals to differentiation in frequency. Then you will do like this and you will get your answer. In this way, B will be the correct answer. So this is a very good question because almost 4 properties you are using in this signal. So this become a favorite question in terms of GATE exam, right? I hope that it is clear, right? Now moving towards the next question, see this one. A continuous time signal is shown in the figure, has Fourier transform x of omega, which is sinc of omega upon 2 pi. Then what is going to be the Fourier transform of x t by 2 minus 3 convolve with x minus t by 2 plus 1. So xt is given. First of all, you need to draw these signals. So in xt, first you will do shifting of minus 3. Then we will do scaling of 1 by 2. Then you will get this signal. Then construct a new signal by shifting +1 and then by scaling by -1/2. Okay, shifting will be done is first, scaling and reversal will be done after shifting. So let me draw these two signals. So if I draw these two signals, after doing the shifting and the scaling, if I draw these two signals, just see what I'm going to get. I believe you people can do the shifting and scaling because we have done this in the last case also. So like that you can do it. Okay, shifting should be done first, then scaling or reversal will be done. So if I draw these two signals, okay, x of t/2 -3 and here x of -t/2 +1. Okay, so I will get these two rectangular pulses. This will be from 5 to 7. The magnitude will remain same because we are not doing anything in the magnitude. And the other signal will be from 1 to 3. Okay, and the magnitude is same. So these are the two rectangular pulses that we have. Okay, now what we have to do here is we have to do convolution between them. Correct. Now you know that convolution in time domain is multiplication in frequency domain. Okay, convolution in time domain is multiplication in frequency domain. If I have x1t convolved with x2t, convolution in time domain is multiplication in frequency domain. Convolution in time domain is multiplication in frequency domain. Okay, so either you can use this property or get the convolution of these signals first and then take the Laplace transform, whatever is feasible to you. You can do the both the things. So let me do the convolution here first. So what is going to be the result of this convolution in time domain? So see, this is a rectangular pulse in which the duration of the signal is 2. This is a rectangular pulse in which also the duration is 2, right? So they are two rectangular pulses of equal duration. Now the convolution of two rectangular pulses of equal duration is a triangular pulse. Okay, convolution of two rectangular pulses of equal duration is a triangular pulse. So you are going to get a triangular pulse, right? Triangular pulse of what? See, triangular pulse, what are the left coordinates? 5 and 1. So left point will be 6, 7 and 3. So right point will be 10. Okay, so we will get a rectangular pulse like this, where the magnitude will be, and this will be 8. The magnitude will be what? Magnitude will be magnitude of one into the magnitude of other into any one of the duration, because they are same. So we will get 2, right? This is going to be the convolution of these two signals. Let me write it y of t. Okay, I am calling this result to be yt. So this is the result of their convolution in time domain. Okay, now I am going to shift this signal. I am going to draw another signal yt plus 8. Correct. So if I will draw another signal which is yt plus 8 from this yt. Okay, so yt plus 8 will become what? It will become a signal like this. Just see. Correct. First I did the convolution, I got this yt, then I have shifted this yt, right? Because my midpoint here is 8, I am bringing that to origin. After doing that, if I take the Fourier transform of this signal, then what is going to be the Fourier transform? So Fourier transform will be, I have a triangular pulse. So see, in first question also we had that same signal. If you have a triangular pulse in time domain, the frequency domain is going to be sample square, right? So what will be the Fourier frequency Fourier transform of it, a tau. Just see, this is our a and this is acting as a tau. So a tau sample square omega tau by 2, right? And because you are taking Fourier transform of t plus 8, so shifting you are doing. So in Fourier transform, how shifting will come? It will come in terms of e to the power. So e to the power j 8 omega will also come. Okay. Up now after that, what is the value of a into tau? So see, a value is 2, tau value is also 2. So we will get 4 sample square 2 omega or sample square omega just, right? Sample square omega e to the power j 8 omega, right? Then answer that we have to give is not in terms of sample, the answer is present in terms of the sink. Okay, so need to convert this into sink. So after converting this into sink, what we will get? And I think I have done some mistake here. This is 5 plus 1 6, 7 plus 8 10, 7 plus 3 10. Okay, now we have shifted it by 8, right? So omega tau by 2. This is rectangular signal, right? So a tau will be what? It will be 8 here, not 4. No, correct. It is correct. A tau will be 4. Just see, a tau, a triangle t by tau is a tau sample square omega tau by 2, right? So what we have done is correct. 4 sample square omega. Now answer is not coming in terms of sample, it is coming in terms of sink. So we can write it sink square omega upon pi e to the power j 8 omega. Means you can convert the sample into sink just by dividing by pi, right? So this is how you can convert the sample into sink, right? This is how you can convert the sample into sink, and this is how you will get your answer, right? So this is the Fourier transform of yt plus 8, right? Yt plus 8. Okay, got it? We got the convolution first, then we shifted this signal, and now we have taken the Fourier transform of this shifted signal. So it is coming like this. Now is there an option? 4 sink square omega by pi e to the power 8 j omega is given in option number A. So this is how you can get it done. Clear, guys? I hope it is clear and you have written it also. Okay, so this, in this way we can solve this particular question. Right? Now after that, move to the next question, question number 4, and now this is related to Laplace transform. So in Fourier transform, we have done some fantastic question. Practice this as many times as you can. Surely you are going to get next time the same type of question in exam also. Now this question is from Laplace transform. Laplace transform of signal xt is formed by convolution operator and final value of xt, where xt is given by, right? So we have to find the final value also, and we have to find the result of this convolution, right? So see, what is given to us, x of t is tut. This is one signal. We have to do the convolution of this signal with another signal, which is cos 2 pi t ut. Okay, so it is like x1 t convolved with x2 t, right? So convolution in time domain is multiplication in frequency domain. Remember this property. So you have to take the Laplace transform of tut and you have to take the Laplace transform of this. So Laplace transform of tut will be 1 by s square, right, into the Laplace transform of cos 2 pi t will be s upon s square plus 2 pi square. Okay, then finally what you will get is 1 upon s square plus 4 pi square. So this will be the answer of the Laplace transform. Okay, then we have to find the final value also, right? So final value, now you can apply the final value theorem here. Okay, so as per the final value theorem, limit t tending to infinite x of t is equal to limit s tending to 0 s x of s, or limit s tending to 0 s x of s is s square plus 4 pi square. Right, now just this will be cancelled and put the limit and you will get 1 upon 4 pi square. So this will be the right answer. From Laplace transform in GATE, you are not going to get a tough or tricky question, right? You have to apply the basic things that you know and you will be able to do complex problems. Correct? I hope this question is clear. It was an easy one which you can solve very easily. Got it? So I hope that it is clear. Now see question number 5. So this is question number 5. The Laplace transform of a continuous time signal is given by x of s, which is like this. What is going to be the RMS value? They have given Laplace transform. You have to tell the RMS value. RMS value can be calculated for a periodic signal. So you need to get the signal and then you have to calculate the RMS value of that. Right? So see, they have given the Laplace transform x of s like 2 by s 1 minus e to the power minus 2s divided by 1 minus e to the power minus 4s. Isn't it? This is like x1s upon 1 minus e to the power minus st, right? Where x1s is the Laplace transform of the signal for first time period, and time period is going to be what? 4, right? So from here you will get that time period is going to be 4. Okay, now x1s is 2 upon s 1 minus e to the power minus 2s, or it is 2 upon s, or 2 I can take right out, 1 upon s minus e to the power minus 2s upon s. Correct? So what could have been the x1t? So if I take the inverse Laplace transform, x1t will be simply 1 minus what I can write, 1 minus see, u of t has Laplace transform 1 upon s. If I have u of t minus 2, then Laplace transform will be e to the power minus 2s upon s. So I can write it 2 times ut minus 2 times u of t minus 2. Okay, so this will give you Laplace transform 1 upon s. This will give you e to the power minus 2s upon s, right? So I got my signal x1t. Now let me draw this signal only. So signal is u of t minus 2, the magnitude is 2, right? And it is periodic. So time period is 4. That means the same signal is going to repeat itself again, right? Correct? So see, this is the time period of the signal. So you have the signal value for the one time period. You have taken the transform only for the first time period part of the signal, and then you have put it in this formula to get the transform of a periodic signal. This is the property. So by the way, you got your signal x of t, which is a periodic signal. Now you have to tell the RMS value of this signal, right? So what is going to be the RMS value of this signal? What is going to be the RMS value of this signal? If you are confused, then calculate power. We have covered power and energy also. So power will be 1 upon time period. Within the time period, signal x of t square dt. Okay, so time period is 4. Okay, and within the time period 0 to 4 your signal is available only for 0 to 2, and at that time its value is 2, right? So just solve it. So what you will get, 4 by 4 integration will give you t, and what you will get finally is 2. So this is how you are getting power. Okay, now power is equal to RMS square, and power you have 2 equal to RMS square. So in this way RMS will be under root of 2 or 1.414, right? So Laplace transform is given and they have asked RMS value. It's a very good question, right? Nicely fabricated question that I have taken here, right? So see, you have to recognize that RMS value will be calculating for a periodic signal. So they definitely, this is the Fourier transform of a periodic signal. A Fourier transform of periodic signal is Fourier transform of one time period of the signal divided by 1 minus e to the power minus st. Correct? Then take the first time Fourier transform, first time period Fourier transform, and try to decode the signal. Then repeat the signal again and again, right? And this is how you will get your signal, and after that you can find the power, and then you can find the RMS value, right? This is how we can solve this question. So this was the question number 5. I hope that it is clear. Now see this question, question number 6. F of t has Laplace transform f of s, which is equals to log s plus 2 upon s plus 3. What is going to be the final value f of infinite? Okay, so what is going to be the final value is what we have to calculate. अब you see that Laplace transform is log of s plus 2 upon s minus s plus 3. Remember one thing, whenever there is log present, to get rid of log you have to differentiate. अब now log is present in the frequency domain, so we will be differentiating in frequency domain. Now ask yourself that when do we differentiate in frequency domain? So we differentiate in frequency domain when the time is multiplied in time domain. So use that property. Okay, we know that t, f of t is equal to minus d by ds of fs, right? So minus d by ds of fs. This is how you will recognize that what you have to do in this question, the way I discussed with you. Okay, now we can write it d by ds of log of s plus 2 minus log of s plus 3. Okay, now after that we can write minus, not just differentiate. So on differentiation you will get 1 upon s plus 2 minus 1 upon s plus 3, or you can write it 1 upon s plus 3 minus 1 upon s plus 2. This is t ft. Okay, now take the inverse Laplace transform. So you will get e to the power minus 3t minus e to the power minus 2t ut. Okay, this is t ft. So what is going to be f of t is 1 upon t e to the power minus 3t minus e to the power minus 2t ut, right? This is going to be your f of t, but you have to find the final value, right? You have to find that what is the value of f of t at t equals to infinite. Okay, so just put limit t tending to infinite f of t, or limit t tending to infinite 1 upon t e to the power minus 3t minus 2t ut. Okay, अब e to the power minus infinite is 0. Okay, and 1 upon infinite is 0. So we are going to get, we can write here 0, right? We can write here 0. 1 by infinite will be 0. E to the power minus infinity, higher powers in e to the power will give you a 0 value, right? So 1 upon infinity is 0. So we can write this 0. So this is how you will be solving this question. So what you have to remember, whenever there is log in the, whenever log is present, to get rid of the log we have to differentiate. Log is present in frequency domain, so differentiation has to be done in frequency domain. Now, when do we differentiate in frequency domain? When there is multiplication of time in time domain is there. Like that, you can recall the property and you can apply it. Correct. So this is how we will solve this question. Now have a look over this one. An LTI system with input and output related with the differential equation, and given that system is neither causal nor stable, then what is going to be the impulse response? Okay, the system is neither causal nor it is stable. Correct. So first take Laplace transform of the differential equation. After taking Laplace transform, you will get s square ys plus 6s ys minus 4ys equal to x of s. Then get y of s upon x of s. That will give you 1 upon s square plus 6s, or 4 was also here, I forget that. 4s square plus 6s minus 4. Okay. And we will call it h of s, the transfer function. Correct. We need impulse response, so we will take the inverse Laplace to get the impulse response. Okay. So this h of s that you have, you can factorize it, and the factors will be s plus 2 and 4s minus 2. Right. After that, you can do the partial fraction, and finally you can write it h of s equals to minus 1 by 10 upon s plus 2 plus 1 by 10 upon 4s minus 2, right? Or I can write it s minus 1 by 2. Okay. So this is how finally you will solve and you will get hs. I hope that you can factorize and you can get the partial fraction done also, right? So in this way, finally you are getting this. Okay. Now take the inverse Laplace transform without thinking anything. So you will get e to the power 2t e to the power minus 2t ut plus 1 upon 10 e to the power t by 2 u of t. Right? This is what you will get. Okay. Up see, what is the ROC from here? The ROC from here is sigma greater than minus 2. ROC from here is sigma greater than 1 by 2. Right now, these are the ROCs. Okay. Now let me plot this situation in front and then realize that what do we have and what do we want. So we have two poles, and those two poles are, we have two poles, one is minus 2 and the other is 1 by 2. Minus 2 is this pole and 1 by 2 is this pole. Correct? These two poles we have, minus 2 and 1 by 2. Now what do we want? We want system to be neither causal nor stable. If the system wants to be neither causal, the ROC should be left side to the leftmost pole. Who is the leftmost pole here? The leftmost pole here is minus 2. So ROC should be left side to it. Then the system will be neither causal. Okay. So for neither causal, we need sigma less than 2 ROC. And right now you can see in this scenario, it is not including the j omega axis. So if the j omega axis is not included, system will not be stable. So right now it is neither causal and plus it is unstable also. And this is what they want, neither causal nor stable. So they want non-causal and unstable system. So what should be the ROC? ROC should be sigma less than minus 2. Okay. Sigma less than minus 2. So see, it is sigma greater than minus 2. It is sigma greater than 1 by 2. So if you have to choose one ROC, what ROC you will choose? Normally, you will choose sigma greater than 1 by 2, because if it is sigma greater than 1 by 2, then it is already greater than minus 2. Right? So right now the ROC is sigma greater than 1 by 2. Right now it is completely right-sided. A completely right-sided system, you want to make it completely left-sided. So what you will do? You will place a minus in front of the result, and u of t will be written u of minus t. Correct? u of t will be written u of minus t. Here also you will do the same thing. U of t will be written u of minus t. So what we will get? We will get 1 by 10 e to the power minus 2t u of minus t minus 1 by 10 e to the power 2t u of minus t. Right? 1 by 10 e to the power minus 2t u of minus t minus 1 by 10 e to the power t by 2 u of t. Correct? This will be the answer. So is it matching with any of the options? Is it matching with any of the options? So it is matching with option number A. If I write minus here, which I have missed, so you can do that correction. Right? Is it matching? I think options are not typed correctly. 1 by 10 e to the power minus 2t u of minus t, right? And e to the power plus t by 2. So where I will find the right answer? I believe that this option is the correct option when I write here minus t. Okay, so just typing mistake is there, guys. You can write minus t here, but I believe the concept is clear. Okay, so first take the inverse Laplace transform. After finding the inverse Laplace transform, just have a look over the ROCs. So right now the ROCs are for a completely right-sided system. We have to find greater than minus 2, greater than 1 by 2. So greater than minus 2 or greater than 1 by 2. So I'll choose greater 1 by 2. A completely right-sided system is given, but we have to write it for a completely left-sided system. Okay. So if a completely right-sided system has to be made a completely left-sided system, you will put the minus before the result and u of t will be written u of minus t. Okay. This is how you will change a right-sided thing to left-sided. After doing these changes, you will get this result, which is given in the option number D. Right, which is given in the option number D, and there was a typing mistake here, minus t should be there. Okay, so I believe this concept is clear. So why I have taken this question? To make this fundamental concept clear to you. Okay, I hope it is done. Now see this question. A discrete time signal is given by what is going to be the period. Periodicity is a very important concept, and scaling, when scaling is done in the periodicity, what happened to the period and frequency is also very important. Right, so in part 1 also we had some question related to periodicity. Right now also I have some question related to periodicity, but this time with discrete signals. So what is going to be the period here? X of n is cosine of pi n over 9 plus sine of pi n over 7 plus 1 by 2. Okay, so if we have sum of two signals in discrete time signals, okay, so these are sinusoids. Ab sinusoids are normally periodic, right? But this happens in continuous time. In continuous time, two continuous time sinusoids are always periodic. There's some will be conditionally periodic. We will check the ratio of time period to be rational or irrational, and then the combined signal will be periodic. In discrete time signal, continuous time sinusoid need not to be periodic, compulsorily periodic. We have to check them individually. If individually they are periodic, the combination will definitely be periodic. So here in discrete time, we don't check for the combination. We check for individual periodicity. In continuous time, we check for the combination. We don't check for the individual periodicity. Correct? So what is the time period here? So it will be 2 pi upon omega 1 into k, or 2 pi upon, what is omega 1? It is pi over 9 into k, or I will get 18k, or n1 is equal to 18 for k equal to 1. Okay, so you can see it is an integer number, so this is periodic. Similarly for this also, n2 will be 2 pi over omega 2 into k, or 2 pi over what is omega 2? It is pi over 7 into k, or it is 14 into k, or this will be equal to 14 for k equal to 1. Okay, so you can see this is also integer, so it is also periodic. Okay, so now what will be the period of x of n? So period of x of n will be LCM of n1 and n2, or it is going to be LCM of 18 and 14, right? And what is the LCM of 18 and 14? It is going to be 126, and that is going to be the answer. So it is periodic with a period 126, right? This is how you will solve question like this. Okay, surely you are going to get a question in the exam also. So I hope this concept as well as this question is clear to you. Now moving towards the next question, question number 10. A signal xt has the following Fourier spectra. Nyquist sampling rate for the signal x square t will be what? Okay, from this signal what information we are getting is that the maximum frequency term, right, the signal xt which is given to us, for this signal xt the maximum frequency term is 400 pi into 10 to the power 3 radian per second, or what will be fm, because answer we have to give in hertz. 400 pi divided by 2 pi into 10 to the power 3 radian per second. So what we will get? We will get 200 kilohertz, right? We will get 200 kilohertz. We have to find the sampling rate of x square t. X square t is also x of t into x of t, right? X of t into x of t. X of t into x of t, when we have multiplication, okay, this has maximum frequency f of m1 which is 200 kilohertz. This has frequency f of m2 which is 200 kilohertz, right? So what is going to be the maximum frequency here? So when we have multiplication, the frequencies will be added, f of m1 plus f of m2. Remember this fact. When we have multiplication, the frequencies will be added, so you will get 400 kilohertz. Then what will be the fs, the sampling frequency? It will be 2 times fm, or you will get 800 kilohertz, and that will be the answer, right? So you know that multiplication x1t into x2t is going to be convolution in frequency domain, right? When you are going to do convolution, in convolution the durations added, right? So frequencies will be added, and that's why I use this particular result, that whenever you have multiplication, the maximum frequency will be addition of, you can make it twice, or if suppose the power is 3, you can make it thrice. Basically we are adding it because it is same, so it becomes twice or thrice, right? So whenever we have multiplication, the frequencies will be added, because here the same signal is there, so it becomes twice. Correct? Why? Because multiplication result in convolution. In convolution, when you are doing, the durations will be added, so 2 frequencies will be added, right? So you can utilize this concept. Instead of x square, you may get any other power also. The same way you have to do here. Okay, this is why I have chosen this question, to remind you this factor. Now have a look over this question. A system is defined by its impulse response. This is a normal system, not an LTI system. This system is stable. This system is causal, non-causal, stable, unstable. Acha, this is LTI system because impulse response is given. Sorry, h of n is 5 to the power n u of minus n plus 5. Okay, what you can see is that n is negative. N is negative means this signal is left sided. It is defined for negative values of time. Correct? For LTI system to be causal, right, the condition is that its impulse response should be 0 for n less than 0. right? Its impulse response should be 0 for n less than 0, means impulse response should not be existing for negative values of t. It is here existing for negative values of t, so it is not causal, right? So this is non-causal. Okay, now when it comes to stability, have a look that we have to put here n values negative, right? We have to put the n values are negative. Okay, so n can have a value from 5 to n can have a value from plus 5 to minus infinity, right? So we can put values from plus 5 to minus infinity, right? So when I will put minus infinity, then what will happen? 5 to the power minus infinity will be 0. That means at infinity still the signal is a bounded signal. So it is going to be stable. So this is non-causal and it is stable, right? So answer will be stable but not causal. I hope it is clear, right? This is how you have to see this factor. Don't see that 5 to the power n will be unstable also. It depends upon what value of n you are putting. If we are putting n value positive here, means n value is positive infinite, yes, it is unstable. But here we have to put n values negative. So 5 to the power minus infinity will be 0 or bounded. So it is stable, right? I hope it is clear. Now see this question. Consider two discrete time systems S1 and S2 described by these equations. Which of the following statements are true regarding stability and causality? Same thing we have to do again. So I believe let us see S2 first, because S2 is an easy one. S2 is having impulse response h of n equals 2 to the power n u of n minus 1. Now you see the exactly same way what we have done right now. N is positive here, means the system is right sided. Okay, the system is right sided. So if the system is right sided and it is LTI system, right, what we can see that Hn is clearly 0 for n less than 0. This condition holds good, so this system is causal. Okay, now n value we have to put positive here, right? N values are positive only. So n value can be infinite also. If I am going to put 2 to the power infinite, I am going to get infinite, which is unbounded. So it is going to be unstable. Correct? So S2 is causal, but it is not stable. Option C is correct. Now let's have a look over S1. What is S1? S1 is h of n equals to e to the power minus 2 modulus of n. Whenever we have seen modulus, how to write modulus? When modulus is giving us negative result, it will be 2 of n, and how the negative time is written in discrete time, minus n minus 1. Plus when the time is positive, then it will give you minus 2n, and how to write positive time, u of n. Correct? Now have a look. So clearly you can see that here the n values are negative. Negative means we can say that h of n is not equal to 0 when n is less than 0. So that means it is non-causal. Okay. Now for stability, here the n values are negative. So I have to put here negative n. So it will become e to the power infinite. Here n values are positive. So I will be putting positive infinite. So it will become minus infinite, which is 0 plus 0. Or 0 is a bounded thing. So this is going to be stable. Okay, I have to look that what are the n values, positive or negative. I will put positive or negative infinite accordingly. Correct? So here I will put negative infinite, here I will put positive infinite, both are giving me 0. Right? So S1 is what? S1 is non-causal, but S1 is stable. Option is B. S1 is stable but not causal. So B and C are the right option. So this is a perfect question for an MSQ question. Right? I hope that it is clear. Okay, guys. So two such questions we have solved, and I hope that your concepts are clear with these questions. Now have a look over this one. Two discrete time signals x1n and x2n are given by x1 and x2. yn is an addition of these two signals. What will be the time period of y of n? Okay, what is going to be the time period? So if I talk about x1n, or if I talk about y of n, which is sum of these signals, so sine of 2 pi n plus alpha plus cos of 3 pi n plus beta. Now let's talk about the time period here. So it will be 2 pi upon 2 pi into k. So you will get simply n1 equals to k, or n1 will be 1, right? For the k value 1, it will be 1. If I talk about this one, n2 will be 2 pi by 3 pi into k, or I will get 2 by 3 into k, or I will get just 2 when k value is 3. So I can get both the time period as integers. So yn can be a periodic signal, and then the time period of yn will be LCM of n1 and n2, or LCM of 1 and 2. LCM of 1 and 2 is 2, so answer will be 2, right? In this way you can solve this question, right? This is an easy question, okay, but given in a twisted way. So I hope that this is also clear to you, correct? Now let us move to the next question, question number 14. Now this is a very important and a good question. Consider the Z transform of a discrete time sequence h of n equals to n plus 1, 1 by 8 to the power n, u of n is hz, then what is going to be the value of h of z at z equals to 0? Before that, I would like to draw your attention towards two convolution results. A to the power n un into b to the power n un, right? What is the convolution? The convolution is a to the power n plus 1 minus b to the power n plus 1 upon b minus a u of n. Similarly, if I have a to the power n un convolved with a to the power n un, then I will get n plus 1 a to the power n un. Okay, these are two important results. Based upon this particular result, you must be realizing something here, isn't it? What we have here, we have been given h of n, which is n plus 1, 1 by 8 to the power n u of n. I can write it 1 by 8 to the power n u of n convolution 1 by 8 to the power n u of n, right? Ab you know that convolution in time domain is multiplication in frequency domain. So what is the result of a to the power n un? What is going to be the z transform of it? So it is going to be 1 upon 1 minus az inverse, right? 1 upon 1 minus az inverse, or I can write it z upon z minus a, right? By using this result, and convolution in time domain is multiplication in frequency domain, so I will get z upon z minus 1 by 8 for this into z upon z minus 1 by 8 for this also, or it will become z upon z minus 1 by 8 square. Now I have to find h of z at z equal to 0. So 0 upon 0 minus 1 by 8 square, or answer will be 0, right? So if you can remember this result, this problem is nothing for you. You can easily score 2 marks out of it, right? I hope this question is clear. Got it, guys? Correct? So these are the important results which you need to practice, okay? In continuous time also, I had a question related to that. There also I told you what is going to be the convolution of these two results in continuous time. In discrete time also, I have a question through which this concept is revised, right? And that is the objective of the gate score booster series. Have a look over this question. Continuous time LTI system is shown below. The input signal is like this. if the frequency response h of omega is a rectangular pulse from -3 to 3 having amplitude 2, then what is going to be the power of output? Before that, we need to know that what is going to be the output. Okay, so have a look over this situation. What is given to us, that the LTI system has an impulse response which is a rectangular pulse, right? Frequency response h of omega, which is a rectangular pulse of magnitude 2 and duration from -3 to +3. Okay, and now we have given it an input signal x of t, which is 5 sine 2t plus 8 cos 4t plus 14 cos 6t plus 30. Okay, now what is going to be the output? So in such a situation, the LTI system transfer function will be acting as a low pass filter. So only those frequencies will be passed which are equal to or less than the frequency of this filter. Frequency here is 3. So what will be passed? Only those frequencies which are less. So only this particular will be passed. So output YT will be what? We will have 5 sine 2t at the output, but not only this, you have to multiply the transfer function magnitude at this frequency which you are accepting. Okay, so what is the transfer function value at this frequency? It is equals to, at 2 we will have 2, so 2 into 5 sine 2t, and then you will get 10 sine 2t. This is your output YT, right? Now what is going to be the power of this signal? So power of this signal is amplitude square by 2. Amplitude is 10 square by 2, and you will get 50, right? Power of a sinusoidal signal. RMS square, RMS value is amplitude by √2. So RMS square, A square, amplitude square by 2, right? In this way you can get this question done. Correct? It was a very good question. Okay, in part 1 also we have done some questions like this, but it was a different question. Here, after getting output, you have to calculate the power of it also. Okay, so this is very important. I hope it is clear. Now let us move to the next question, and the next question is, see this question. A discrete time system is shown in the figure, okay, where xn is the input, yn is the output, the impulse response is also given. Then what is hz? What is hz, and whether it is stable or causal, that also we have to comment, right? Chalo, let's see. We have been given h of n, and h of n is -1 by 2 to the power -n u of -n -1. Okay, or we can write it -2 to the power n u of -n -1. Right? When you look into this system, you can see that n is negative. N negative means it is left sided. So left sided means the ROC will be sigma less than to the pole value. What is the pole value? Whatever is written here as a to the power n, that will be the pole value, right? So we got the ROC. So you know that h of z will be 1 upon 1 minus AZ inverse. A value here is 2, Z inverse. So we will get this AZ, HZ. Okay. Now, whether this is causal, non-causal, stable, unstable, that we will see. Okay. So I believe that you know these formulas, that if you have a to the power n un, the Z transform is 1 upon 1 minus AZ inverse with ROC greater than A. If we have minus a to the power n u of -n -1, then the Z transform is same with ROC less than A. Okay, that's what we have used here. Now let us see that with the whether this system is causal, stable, or whatever it is. So we have the ROC less than 2. Okay, we have the ROC less than 2. This is the pole value. The ROC is less than 2. Now, where will be the unit circle? Where will be the unit circle? So, unit circle will be somewhere here. Okay. This is unit circle. Up now, whether this ROC is including unit circle, answer is yes, right? If it is including unit circle, it is stable, right? Because ROC is including the unit circle, correct? Now, whether ROC is inside to the circle, the answer is yes. So, it is non-causal. For a causal system, ROC will be outside to the circle. Here, ROC is inside to the circle, so it is non-causal. So, it is non-causal because ROC is inside to the circle. It is stable because ROC is including the unit circle. Correct? So, which one will be the answer? 1 upon 1 minus 2z inverse, unstable, not unstable, it is stable, stable and non-causal. Option number C is the right answer. Right? So, this is also a very good question. And see what trick I told you. Looking into the n value, you can determine everything here. Okay, you can get everything related to n. Correct? I hope that it is clear. Right? Then see the next question. Now, see a question like this. If x of n is 1 by 2 to the power modulus of n, then what is going to be the ROC of x of z? You don't have to find the z transform, right? X of n is 1 by 2 to the power modulus of n. Whenever we have modulus, what we have to do? Modulus of n will have a value minus n, right? And this, it will have the value minus n when the n value is less than 0. Right? N value less than 0, n is time here. So, how to write the negative time in discrete time? U of minus n minus 1. Now, when n is positive, 1 by 2 to the power n, U of n. Now, you can adjust it and you can write it 2 to the power n, U of minus n minus 1, 1 by 2 to the power n, U of n. Okay, up now see. The time here is, n here is negative. Negative n means it is left sided. Left sided means ROC will be less than to the pole value. Pole value is 2 here. Okay. Similarly, if you see here, n is positive. Positive n means it is right sided. Right sided means ROC will be greater than to the pole value. Pole is 1 by 2 here. Right. So, greater than 1 by 2 and less than 2. Whenever you have to choose the ROC, you just draw the circle and you will get an idea in Z transform. Okay, so we need two circles. One is the radius, one is having the radius 2, another is having a radius 1 by 2. Right, so this is 1 by 2 and this is 2. Now see, less than 2 and greater than 1 by 2, so you will get a strip. So what will be the ROC? Sigma greater than 1 by 2 less than 2. This will be the ROC, so this will be the right answer. Correct. Modulus is a very important thing. You will certainly get something related to modulus in Sigler, and this is how modulus has to be treated. Clear, guys? Chalo, I hope it is clear. Now move to the next question. See this one. So in this question, it is given that it is a stable LTI system has system function. Then what will be the impulse response for this ROC? Okay, what will be the impulse response for this ROC? So first of all, h of z is given to you 1 upon 1 minus 2z inverse 1 minus 1 upon 3 z inverse. First of all, you have to do the partial fraction. Okay, so I have done that, and the partial fraction will give you 6 by 5 upon 1 minus 2z inverse plus minus 1 by 5 upon 1 minus 1 by 3 z inverse. This is h of z. Correct? Then if I take the inverse z transform, then I will get 6 by 5 2 to the power n u of n. Okay, without considering any ROC, I am just taking it for right sided ROC. minus 1 by 5, 1 by 3 to the power n u of n, right? If you see here, then what is going to be the ROC? Sigma greater than 2. From here, the ROC is going to be sigma greater than 1 by 3. Okay. But we have to write the result for an ROC Z greater than 1 by 3 and less than 2. Okay. So see, we want to write it for Z greater than 1 by 3, and this is a perfect match. This is also given for greater than 1 by 3. So we will not change this result. You just write this result as it is. Okay. But here it is greater than 2, but we have to write for less than 2. So if right sided system we have to make left sided, we will put a minus before. Okay. And u of n will be written u of minus n minus 1. Okay. So this is going to be h of n. Now where this is given as option, just have a look. I believe this is not given anywhere in these options. Minus 6 by 5, 2 to the power n, u of minus n minus 1, right? So none of these options are having this option. Okay. What you have learned from this question? First, you take the inverse Z transform, determine the ROC by naked eyes, whatever you can get for right-sided system. Then you have the ROC. Now you write the system for the given ROC. So whatever is matching will be written as it is. Whatever is not matching, the right-sided thing you want to convert left-sided, you will put a minus before, and n will be written minus n minus 1. Right? In Laplace, we have written minus before and t will be written minus t inside ut. Here, minus will be written before and u of n will be written u of minus n minus 1. That's the only change that you will do. And none of these options are having this option, right? So this is how you will solve these questions. I hope you are getting a clarity over these topics and the tricks that I'm telling you. And you can see that you are solving this question just by in 1, 2 or 3 steps without consuming much time. Okay. And that is the purpose of this series. Now see this question. The inverse Z transform of x of Z for ROC Z greater than 2 is x of n. Then find the value of x of 3 and x of 2. ROC is given Z greater than 2. Whenever ROC is greater than, you will arrange your xz in descending powers of Z, which it is already arranged. If ROC is given less than, then you will arrange your xz in ascending powers of S. Okay, remember this thing. So here ROC is Z greater than 2. So you will arrange the xz in descending powers of Z, which it is already arranged. After that, just divide 2z square minus 3z plus 1. We have to divide by z. Why we are going to divide? Whenever we have to find the coefficient, we will do this thing. Remember, whenever we have to find the coefficient, we will do the division. अब division will be done by arranging in descending order if ROC is greater. If ROC is less, we could have arranged it first in ascending orders of Z, then we could have divided. Okay, so remember these facts. Now just simply do the division. So what we will do, to bring Z here, what I have to multiply in 2z square, the answer is 1 upon 2 Z inverse. So multiply it, then you will get Z here minus 3 by 2 plus 1 by 2 Z inverse. Now change the signs. Okay, after changing the sign, this will be cancelled, and what you will get is 3 by 2 minus 1 by 2 Z inverse. To bring 3 by 2 here, what I have to multiply here? So I have to multiply here 3 by 4. Okay, so let us multiply 3 by 4 Z inverse. Okay, Z to the power minus 2. When you will multiply it here, you will get 3 by 2 minus 9 by 4 Z inverse plus 3 by 4 Z to the power minus 2. Then this will be cancelled, and from here what you will get? You will get 7 by 4 Z inverse minus 3 by 4 Z to the power minus 2. Okay. Now with what factor I should multiply here so that I'll get 7 by 4 z to the power minus 1? Tell me. So I should multiply with 7 by 8. 7 by 8 z to the power minus 3. If I do that, I'll get 7 by 4 z to the power minus 1. If I multiply here, I'll get 21 upon 8 z to the power minus 2 plus 7 by 8 z to the power minus 3. Now don't do anything. You got your result. Okay. So we had x of z, which is z upon 2z square minus 3z plus 1. Okay. So after division, what we are getting is 1 by 2 z to the power minus 1 plus 3 by 4 z to the power minus 2 plus 7 by 8 z to the power minus 3, right? Ab, I believe that you remember the Z transform formula. So as per the Z transform formula, x of z is summation n equals to minus infinite to plus infinite x of n z to the power minus n, right? See, ROC was given greater than, so we only can put the value of n positive. If you are going to put positive values of n, z power will always be negative, right? So if I put the n values 0 to infinite x of n z to the power minus n, then what I will get? I will get x of 0 and z to the power 0, means there will be no coefficient. X of 1 z to the power minus 1, x of 2 z to the power minus 2, and so on, right? So based upon that, can you tell me that what is going to be x of n? What is x of 0? X of 0 means where there is no z to the power, it is not present here, so it will be 0, and that is going to be my n equals to 0 component. Then z to the power minus 1 is present here, so that coefficient will be 1 by 2. So this is my n equals to 1 component. Then z to the power minus 2 is having a coefficient 3 to the power 4, and 7 by 8 is the coefficient for n equals to 3, right? So in this way you got the value of x of 3 minus x of 2. So what is x of 3 minus x of 2? X of 3 is 7 by 8, x of 2 is 3 by 4, right? So how much we will get? We will get 7 minus 6, that is 1, 1 by 8, or 0.125. Correct? This is how you have to solve these questions. Whenever we have to find some coefficient, we will take the help of division, right? ROC was greater, so we will arrange in the descending order, then we will divide. We will always get positive coefficient. If ROC was less than, we will arrange in ascending powers, and when you will differentiate, you will get negative powers. Sorry, you will get positive powers of z and negative coefficient, right? So remember this thing, and you will be able to solve one gate question. I believe it is clear. Okay. Then have a look over this question. This is from DTFT. A 5-point sequence xn is given as the values are given. Let x e to the power j omega denotes the discrete Fourier transform. Then what is going to be the value of this integral? Okay. I would like to draw your attention towards the formulas. If x of n, we are calculating the DFT. Okay. If we are taking the DFT of it, then what is the formula? Summation n equals to minus infinite to plus infinite x of n e to the power minus j omega n, right? Or inverse DTFT formula is x of n is 1 upon 2 pi minus pi to pi x of e to the power j omega e to the power j omega n. Correct? Now we will take the help of this formula, inverse DTFT formula. Okay. In this inverse DTFT formula, this is the formula for inverse DTFT, right? Now let us take the help of this formula. Okay, so if I take, this is dtft, not dft, right? And this is the formula for inverse dtft. In this formula, if I put n to be 0, then what I will get? I will get 2 pi x of 0. This is equals to minus pi to pi x of e to the power j omega and d omega. Correct? And this is what we have to find. We have to find the value of this integral. So this integral is what? This is equal to 2 pi x0. Now what is the value of x0 here? Is equal to 5. Right? So you will get 10 pi, and 10 pi is the answer. Correct? DTFT, a complex topic, but a very easy problem is asked. Inverse DTFT formula is only what you have to know. Right, guys? I hope it is clear. This was an easy question. This was an easy question. You can make it look easy if you remember these formulas, okay, and this trick. Then see this question. Question number 21. If xk be the 6-point DFT of a sequence, then what is going to be the value of x3 plus x0 upon x3 minus x0? Now we are talking about DFT, right? What are the formulas? If xn has DTFT, which is denoted by x of k, then the formula says that it is equal to n equals to 0 to n minus 1 x of n e to the power minus j 2 pi by n into k into n. This is the formula, right? Where what is n? N is number of samples. Right? How many number of samples we have here? 1, 2, 3, 4, 5, 6. We have 6 samples here. Okay. Up we have few properties also. We have to find here x of 3, which is equal to x of k, where k is exactly equal to n by 2. Okay. So this is among the properties. If it is like this, then this will become n equal to 0 to n minus 1 minus 1 to the power n x of n, or in our case it is n equal to 0, n minus 1 is 5 minus 1 to the power n xn, or n equals to 0 will give you x of 0 minus n equal to 1 x of 1, n equals to 2 x of 2, n equals to 3 minus x of 3, n equals to 4 x of 4, n equals to 5 minus of x of 5. Up now all the values are given. This is 1 minus minus 2 plus 3 minus minus 4, okay, then plus 5 minus minus 6, right? Add them all and you will get 21, right? And then after that we have to find x of 0. So whenever we have to find x of 0, this is equals to summation n equal to 0 to n minus 1. Just put k here 0. If you will put k here 0, this will become 1 and this will become simply like this, or it is equals to sum of all samples of x of n. So just add all the samples, 1 minus 2 plus 3 minus 4 plus 5 minus 6, and you will get 3 from here, right? In fact it is minus 3. Okay, then see, we have to find the value of x of 3 plus x of 0 upon x of 3 minus x of 0. What will be the value? X of 3 is 21, x of 0 is minus 3. 21 minus 3. 21 minus 3 is 18. 21 plus 3 is 14. What answer you will get is 0.75. Correct? So you have to remember these important things here. Okay, the formula of DTFT, which is not an easy thing to apply all the time. So you need to take the help of these properties. Okay, if this is asked, you can do it like this. If this one is asked, you can do it like this. Okay, you should know these important properties of dt dft, and that will simplify the things for you, right? I hope it is clear, right? It was a very good question. Now see this one again, dtft. Ab in last question you have solved only this part of the integral. Ab now in that part they have included this one also. Okay, so what you will do? So write IDFT formula, IDTFT, inverse DTFT formula, right? So inverse DTFT formula is x of n, this is equals to 1 upon 2 pi minus pi to pi x e to the power j omega e to the power j omega n d omega. Okay, last time we put n equals to 0. So this was not present. Here you can see with this integral, this is coming. So what I should put for n? I should put n equals to minus 2, and then you will see that x of minus 2 will be 1 upon 2 pi minus pi 2 pi x of e to the power j omega e to the power minus j 2 omega d omega. Okay, and this is what we have to calculate. So the value of minus pi to pi x of e to the power j omega e to the power minus j2 omega d omega is 2 pi x of minus 2. What is x of minus 2? This is n equal to 0. This is n equals to minus 2. So the value of x of n minus 2 is given 1. So you will get 2 pi or 6.28 as the answer. Right, 6.28 will be the answer. So this is just a modification of the last question that we have done. Okay, so how they have modified it, right? You have to see that. Okay, last time we put n value 0 when there is no exponential here. Right now we have put n equals to minus 2 to get this as a match of the given thing. Okay, so in this way you could have solved this question. Correct. Now see the last question for the day. The input and the impulse response is given for an LTI system. The output of yn is related to Vn, like Vn is a signal formed by y of 2n plus 1. First of all, get yn, and then whatever they are asking, you can find that. Okay. So what is y of n? For an LTI system, y of n is convolution between x of n and h of n, right? So let us find the convolution. So use the tabular method and get the convolution. So let me write x of n here. What is x of n? 1, 2, 1 and 1, and the arrow is put here. And then write h of n here. You can write them anywhere. It is 1, 1, 1 and 1. Okay, and the arrow is put here. Now just multiply all the components here. 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 1, 1. Okay, now just add them diagonally. Correct, just add them diagonally, and then you will get your y of n. So what is going to be y of n? 1, 3, 4, 5, 4, 2 and 1. Okay, and now where you will put the arrow? So just see, these arrow points are coinciding at what point? So these arrow points coincides at the third addition, third diagonal element, right? So third diagonal element is this element. So this will be the n equals to 0 point. Okay, so this is how you will get y of n. We got our output by doing convolution. Now they are saying that yn is related to vn, and vn is formed by doing scaling and shifting in yn. So just do the shifting first. Form y of n plus 1. Y of n plus 1 will be nothing difference. You will get the same signal. Plus 1 means arrow will be shifted here. Okay. Now after that you are forming y of 2n plus 1, means you are doing scaling and you are calling it v of n. So this will be You are scaling with 2. So you will only choose those positions which are multiples of 2. This is multiple of 2 and this is multiple of 2. So we will choose 3, 5 and 2. Right? This is our V of n. Correct? This is V of n. So you got your V of n. Half the job is done. Now we have to evaluate this integral. Okay? We have to evaluate this particular integral. Correct? Now what is this integral? So see, if I use Parseval's theorem, then energy of x of n, energy of x of n is summation n equals to minus infinite to plus infinite x of n square. This is equals to 1 upon 2 pi minus pi to pi minus pi to pi x of e to the power j omega, or simply x of j omega you can write, square d omega. Okay, you can write x of e to the power j omega or x of j omega. This is denoting dtft, right? You can write anything. Up now see, this is Parseval's theorem, so you can find it a match what is given here. But not only match, they are differentiating also. They are differentiating also. So differentiation is done in frequency domain. Now when do we differentiate in frequency domain? When we have multiplied with time in time domain. Okay, so if I am multiplying here, with time, time means n, in the time domain, then what I should do? I should do the differentiation here. Okay, so I should write it j d by d omega of x of j omega square d omega. Now you know that modulus is there, so j will be collapsed, right? So finally what you will get? Finally I can write it 1 upon 2 pi minus pi to pi d by d omega, modulus and j we can remove, d by d omega of x of j omega square d omega. This is equals to summation n equals to minus infinite to plus infinite n x of n square, right? अब instead of x we have v here, so let me replace x by v, right? So I can write it v and I can write it v here. Okay, so the value of this integral is summation n vn square. Now see the vn only has 3 samples, one at n equals to 0, another at n equals to -1, another at n equals to +1. Okay, so see, just put the value. When n is -1, the vn is 3, so -1 into 3 square plus. When n is 0, vn is 5, 0 into 5 square. When n is 1, it is 2, so 1 into 2 square, and when you will solve it, finally it is going to give you 13. Okay, this will be 0, this will be 9 and 4, 13, and 13 is going to be the answer, right? So a lot of things they have given in this question, but we decoded everything. Okay, first we calculated yn, then we have shifted yn, then we have scaled yn. Now how to do scaling, shifting in discrete time system, you should have a conceptual clarity. I told here also, right? I hope it is getting clear. Now see this integral, where you have seen this integral. Whenever there is x of j omega square or x of n square is there, you should always try to write Parseval's theorem. I have written Parseval's theorem. Energy of xn is calculated by using this formula, right? In this formula, the frequency domain is differentiated. So I recall that when I will differentiate frequency domain, when I have multiplied time in time domain. So now I got what I have to do, and then I just expanded the things and got the answer, right? So this was the final question for part number 2. In part number 1, we discussed 22 questions. In part number 2, we discussed 23 questions. These 45 questions are well designed, well curated questions. I tried to recall all the concepts and the tricks that one should be aware of in signal and system. If you will practice these number of questions, believe me, you are going to do well in all the signal and system part in the GATE exam, right? So watch this video, part 1 and part 2, and share with your friends also, so all of them will be benefited, right guys? So this is what I wanted to cover. If you have not joined our Telegram channel, you can join our Telegram channel. So whatever we are going to cover in future, you will get regular update. And if you wish to prepare with IMS GATE Academy, if you really like the teaching and learning methodology of IMS GATE Academy, you can join our live online program for GATE 27 or 26, right? By calling on these number. If you will join, you will get these number of benefits also, right? Which nobody else is offering. And just see, right now for GATE 26 aspirants, our test series is live. So you have seen how good quality questions I have discussed with you. You can join our test series. You will find even more good question in our test series, right? So if you are competing well in this test series, surely you are going to score good marks in GATE 26 also. Just have a look over the toppers that we have produced in GATE 25 and in GATE 24. They are right now at very good places. You can also be the next one, right? So with this, thank you so much for watching this video. Watch the part number 1 and part number 2 of signal and system. Apart from that, you don't have to do anything. Everything will be recalled and revised. Practice these questions as many times as you can, guys, right? With this, I would like to end this video, and I will come with control system part 1 and part 2 in upcoming days. So be ready for that also. Thank you so much for watching this video.